Hello students, I am continuing wave optics topic. So in this session I am explaining refraction of plane wave at rarer medium and refraction of plane wave at denser medium. Let us start with refraction of plane wave at rarer medium. So before starting this, so I would like to take one XY interface. So this is a XY interface. Interface means it's a boundary which is going to separate the two medium. So upper portion of the medium is a rarer medium which is having a refractive index N1, and the lower portion of this XY interface is a denser medium which is having a refractive index N2. Assume that a spherical wave is now moving towards the XY interface which is having a speed V1. Then we have to indicate the direction of this spherical wave by these arrow marks. Then we have to take a part of this spherical wave. Part of a spherical wave is a plane wave. We have already studied it. So let us take the part of spherical wave which is a plane wave. Which this plane wave will be called as incident plane wave which is falling on XY interface but not parallel to the XY interface because of this angle. So its one end touches the XY interface first. So this is the direction of incident plane wave, and this is the one end A which has already touched the interface XY, and its other end B is away from this XY interface by a distance BC. Now we have to calculate this BC distance. So we have to assume that this B end initially moving in a rarer medium which is moving with a speed v1. Now we have to measure the time, how much time it will take to travel from B to C. Then if we get that total time, then we have to multiply that time duration with the speed v1 to get the distance bc. Let us assume that its B end is now moving with a speed v1. Hopes you understood. So this is how it is moving from B to C. So from B to C it is moving and it is taking time t seconds. If I multiply V1 and t, then I get the distance traveled in a duration t seconds from B to C. Distance equal to speed multiplied by time. So this is what that distance V1 into t, the incident plane wave has traveled from B to C. So now its other end, A end, now it is already touched the interface. If it start its journey, now it is going to enter into the denser medium. It will start to travel in the denser medium. So since the incident plane wave is having a speed v1, but with the same speed, it is not moving in the denser medium. Once it enter into the denser medium, obviously its speed will decrease. So now because of decrease in the speed in a same time t seconds, it is not going to cover the same distance bc in the denser medium. It is definitely going to cover lesser distance. Assume that this A end is now traveling into the denser medium. So like this. Now this A end this A end is now traveled into the denser medium and it has covered lesser distance because of decrease in the speed. So now we have to calculate how much distance it has covered in the denser medium. So like in the rarer medium, we have multiplied speed and time taken. So same time taken it has taken to travel in the denser medium. Now we have to calculate how much distance it has covered in a same time t seconds. So assume that in the denser medium its speed is v2. Just multiply this speed v2 with the time taken. Then you get a distance v2t. So this is a distance covered in the denser medium. So now we have to take this distance as a radius and A as a center. This is a very important step. You have to take the distance covered in the denser medium by this incident plane wave, and we have to take this distance as a radius, A as a center, then draw one sphere around the point A like this. This is a sphere. In the two-dimensional, it looks like a circle, but assume that this is a sphere which is having a center A and which is having a radius V2 into T. Now, to construct the refracted plane wave in the denser medium, we have to draw the tangent from the C so that it touches the this sphere somewhere at a particular point. It is going to touch the spherical surface. So like this, if I draw the tangent, now it is going to touch the sphere at point E. Now this CE will be called as refracted plane wave, and which is traveling in this direction. You see the direction of the incident plane wave and the direction of the refracted plane wave. Both are different. Then if I draw the normal at point A, then the angle made by the direction of the incident plane wave with the normal will be called as angle of incidence, and the direction of the refracted, this is the direction of refracted plane wave. The angle made by the direction of the refracted plane wave with normal will be called as angle of refraction. Now we have got this diagram ready for the derivation of Snell's law. So with this diagram, with the help of this diagram, we are going to derive the equation of Snell's law. So for that, we have to take two important triangles, A, B, C. Another one is A, E, C. If I take ABC triangle, and for the angle BAC, the angle BAC is I. For this angle, the opposite side is BC, hypotenuse side is AC. Similarly, for this angle R, the opposite is AE, hypotenuse side is AC. So if this is the angle of incidence, then this must be angle of incidence I. So now this angle must be equals to angle of incidence. If this is the angle of refraction, then for the triangle ACE, angle ACE must be equal to angle of refraction. So let us take the first triangle ABC and write the sine of I value. So sine I equal to opposite BC divided by AC is hypotenuse side. So value of BC is V1 into T divided by AC. Write it as equation number 1. Then for the triangle ACE, write the sine value. So sine R equal to opposite AE divided by hypotenuse side AC. AE upon AC. The value of AE is V2T divided by AC. Write it as equation number 2. Then take the ratio sine I by sine R. Then we get V1 by V2 as AC and T get cancelled. Then if I take the value of V1 from this formula, V1 equal to C by N1, I am expressing the speed of light in the rarer medium and V2 the speed of light in the denser medium in terms of the absolute refractive index. The absolute refractive index of rarer medium is N1, whereas N2 is the absolute refractive index of denser medium. So I am expressing this V1 and V2 in terms of the absolute refractive index N1 and N2. So according to this, V1 equal to C by N1, V2 is equal to C by N2. If you substitute the value in the above equation, then the equation turns into N1 sin I equal to N2 sin R. So this is nothing but the Snell's equation. So very important equation it is, and how to remember this equation. Now this is a Snell's law of refraction. So in the examination, you have to draw this diagram with a proper labeling. You have to indicate the incident plane wave, refracted plane wave, angle I, R, and with the help of geometry, you have to show that BAC equal to angle of incidence, angle ACE must be equal to angle of refraction. Then with the help of this diagram, You have to write these two important equations, sin I and sin R, take the ratio and take the help of these two equations, v1 equal to c by n1 and v2 is equal to c by n2. You have to remember this equation. Then you will arrive at the equation n1 sin I equal to n2 sin R. This is nothing but Snell's law of refraction.